Now this time around, we have this function from 0 to that cosine of that dx is equals to from 0 to pi by 2 sine power n of x dx is equals to root of pi gamma of 1 plus n plus 1 over 2 2 gamma of n plus 2 over 2. So let's start with the cosine part. Let's start with this from 0, proving this, that from 0 to pi by 2 cos power n of x dx is equals to root of pi gamma of n plus 1 over 2 over 2 gamma of n plus 2 over 2. So we start with our solution actually. Then we shall say from this function dx. So we want to put it in form of the trigonometric function of what? Of gamma actually. So that is the same as, so if we introduce a 2 here, so we multiply by 2, we divide by 2, so that it be like as if it is still 1. So pi by 2, we have cos of n of x. Then we don't have the sine part, but in that function we always have the sine part. So it's just same as adding sine power 0 of x dx. We believe that this part here is equals to this other part. Then we can continue by that half times 2 from 0 to pi by 2. We can now change this because we want it to look into like 2 times something minus 1. That's how that the function is always designed, so that we can be able to get which beta is it. So we are going to have cos. Now if I say 2 into n plus 1 over 2 minus 1, we believe that this 2 is going to divide by this. We remain with n plus 1. N plus 1 minus 1, we go back to n. So this power here is the same as that upper power. Then for the sine, if I say sine of 2 times a half minus 1 of x dx. So this 2 is going to divide by this, remain is 1 minus 1, which takes back to 0. It takes us back to 0. 2 is going to 2 is going to divide by that, then we remain with 1 minus that 1, which takes us back to 0, the upper 0. Therefore we continue. This will be equals to times 2 into, let's make it somehow look good, cosine of 2 into n plus 1 over 2 minus 1 sine of 2, sorry, it is so above, minus 1 of x dx. But we know that 2 from 0 to pi by 2 cos of 2 into n plus 1 over 2 minus 1 of x sine of 2 into a half minus 1 of x dx is the same as beta of bit of n plus 1 over 2 and a half. This should be a half. It's the same as that. We just pick we pick this and this from that function of ours. Later we shall see what the function is. Therefore it is going to be like a half. These two went with all of it. All of this up to here is beta of that. Half into beta of bit of n plus 1 over 2 and a half. But we also know that beta of n plus 1 over 2 and a half is the same as gamma half gamma of n plus 1 over 2, yes, divided by gamma of this a half plus n plus 1 over 2. What will that give us? That takes us to gamma half. Actually, this is gamma half, sorry. Gamma half is the same as root pi. Gamma of n plus 1 over 2 over this LCM is there. LCM is 2. Then on top we shall have this one comes and add that. So we shall have n plus 2. Gamma that. Therefore, we bring this here is what we've been working on. And it is the same as this. Therefore, it is just a matter of putting a half of pi gamma of n plus 1 over 2 over gamma of n plus 2 over 2. Therefore, this other function of ours, here from 0 to pi by 2 cos power n of that dx is the same as root of pi gamma of n plus 1 over 2 divided by 2 gamma of n plus 2 over 2. So we have proved that first part. Therefore, considering, let's now look for the second part. Now, considering the sine part, which is from 0 to pi by 2 still, sine of n of x dx, that should also equals to root pi gamma of n plus 1 over 2 over 2 gamma of n plus 2 over 2. Yes. Then we make it again like the way we started. Solution, can have our solution. So we have this function pi over 2 sine of n dx. We are going to still introduce the half times 2. It appears as if it is 1 pi by 2. Then this time around we have a sine of n power n. Then the cos we make it now to power 0 dx. So this one, let me hope we shall go in very fast. Times 2 from 0 to pi by 2. We do the same thing here, changing this power so that it becomes something 2 times something minus 1, which is 2 into n plus 1 over 2 minus 1 of x times cos 2 into a half minus 1, because we said this, if we had to simplify this, we go back to n. If we had to simplify this power, we go back to 0 of x dx. Therefore, this, like we did above, this now becomes beta of n plus 1 over 2 and a half, and we say this is the same as a half a half gamma of a half gamma of n plus 1 over 2 gamma half divided by gamma of n plus 1 over 2 plus a half, which gives us gamma half is root pi, and we remain with gamma plus 1 over 2 divided by 2, LCM is 2, then this adds to give us n plus 2. Therefore, this function sine power n of x dx is equals to root pi gamma n plus 1 over 2 divided by 2 gamma of n plus 2 over 2. So since this upper, the cosine part is also equal to the same, and this sine part is also equal to the same, therefore we conclude by saying that integral from pi by 2 cos power n of x dx is equals to, from this pi over 2, sine power n of x dx equaling to root pi gamma of n plus 1 over 2 divided by 2 gamma of n plus 2 over 2. So we've proved it. Thank you for watching this video.